So, my name is Alex, or Ape65, and I'm a municipal engineer, which does not mean I work for a city. It means I design municipal infrastructure for a consulting firm. And our firm works for cities, so we do the design work for the cities. In this short video, it's going to be educational. I'm going to show you how to identify municipal infrastructure. So I'm located in a small suburb near Montreal. Very quiet residential streets. Municipal infrastructure, well, sorry, I'm trying to get used to this camera, how to frame my face here. Big fat face. Alright. Municipal infrastructure is essentially a series of networks. And today we're going to identify 10 networks. 2 of them are on the surface and are quite easy to identify. 4 are underground, and you have to be aware of the clues of what you can see at the surface to identify them. And 4 are up in the air because they're basically cables held up by wooden posts. So here goes. Okay, this is a fairly typical suburban street corner. This neighborhood is about 50 or 60 years old, and the infrastructure is probably around the same age. Now, the 2 surface networks that are quite obvious are the streets and sidewalks. We'll come to those later. Now, the best place to identify underground networks is the street corner, because you see some of the municipal cast iron. So the 4 networks that are underground, you've got storm sewers, sanitary sewers, water mains, and natural gas. Now here, some older neighborhoods, you have a combined sewer system, so the storm sewers and sanitary sewers are basically a single sewer where both rainwater and your sewage flows through it. Here we have both, and a clue as to why we have both is that at the corner you'll probably see 2 manhole covers, one diagonal to the other. When you have sewers, you have to you need a manhole whenever you have an intersection in the sewer system, and when you have a change in diameter of the sewer. So you know, this is in French because we're in Quebec. Égout pluvial means storm sewer, and here égout sanitaire means sanitary sewer. So you know that you have a storm sewer running here in this axis, and next to it you have a sanitary sewer. And since this is a street corner, on the other street the sanitary sewer probably goes this way and the storm sewer this way. And notice all the catch basins that plug into the storm sewer. Now, most of the water flowing from the storm sewer is collected by these catch basins, essentially surface runoff, not only from the street but from the surrounding terrain. The other network is the water main network, and clues you can see are these valves. Actually, these aren't the valves, these are accesses to the valves, but essentially this is like a tube with a little cover. And the valve, this would be a butterfly valve, so essentially at the top of the valve there's a nut, and if you want to shut the valve, you remove the lid and you have a tool which is a key. It looks like a capital T, and the cross portion stays out. That's what you need to turn it. You stick it down, you insert it into the nut, and then you can turn the valve and shut it that way. So there's always valves at street intersections, so that if you need to maintain the water system, you can isolate it for a particular street. So you can guess there's going to be a water main in this axis along this street, and a water main along this axis, and this water main obviously continues probably here. Now the interesting thing, okay, this is a three-way intersection, but you don't need three valves if you want to isolate, for example, the water main that goes this way. If you want to isolate this one, all you have to do is shut that valve and you shut that valve. So if you have, say, a three-way intersection, you only need two valves. If you have a four-way intersection, you only need three valves. See, the water mains are essentially useful for drinking water and household needs. But another very important use for these water mains is fire protection. And in fact, when you design water mains, often the dimension of the water main depends more on the need for fire protection. So usually there will be a fire hydrant like this at each street corner, and if you have a long block, you may even need extra fire hydrants between street corners. Spacing of fire hydrants, that's a rather complicated formula that depends on the type of buildings that are prevalent and the water pressures that are available. Anyway, we're not going to go into those details. Now, the fourth underground network, I know it exists because they installed it here a few years ago, but you see no trace of it. It's the natural gas network, which I know is running under this sidewalk. I know there's a natural gas line running under this sidewalk because it was installed about 2 years ago. And the way they installed it, they used a technique called directional drilling. Essentially, what it means is that the only trace of it is that you see about every 50 meters or so a new patch of sidewalk. Because to do the directional drilling, they have to demolish the sidewalk, but just a few segments every 50 or 100 meters, I don't remember. And then they run, because gas, for the local distribution like this, the gas runs through a fairly flexible small pipe. So they send kind of a robot that will excavate a hole and pull the pipe under it until it reaches the next opening under the sidewalk. And that way they're able to install gas under the sidewalk without digging a trench. And you see hardly any traces of it. We've seen underground infrastructure networks. Now we're going to take a look at aerial infrastructure networks. This is a very simple example. It's easy to understand. Essentially these aerial networks, they're electrical cables on wooden poles often. That's the cheapest form. And this is the simplest example I can find. You have four networks. You have street lighting, electrical power, telephone, and cable. And here's an example of a fairly typical street light. I believe, I don't design this sort of thing, but you know, I know a bit about it. I believe the upper line is the street lighting, and then you've got electrical power, and then underneath, I'm not sure which order, you've got telephone and cable. Now this is the, if I go to electrical power, you have a hierarchy of networks. You start with sort of the large scale high voltage networks, and then through three of those transformers the current is stepped down to lower voltage, which is a more and more local network. And this is the most local you can get. This is the 120, 240 volt distribution network that taps straight into your house right here. So basically where we are here, it's essentially the end of the line for the electrical network, where you're at the lowest voltage.